Breaking news! Singapore's fuel supply has reached the red zone. All electricity will be cut until further notice.
Our energy consumption is increasing rapidly as Singapore continues to develop. And this is what we will see if we continue to deplete the finite amount of fossil fuel. There is an urgent need for Singapore to develop other forms of renewable energy in order to sustain the high demand of energy and reduce our reliance on external sources.
There are many ways to sustainably generate electricity, wind, hydrothermal and solar being the most obvious. But how many are applicable to Singapore? Wind farms are simply enormous windmills designed to generate electricity. However, they cannot be effectively applied to Singapore. We simply don't have the wind speed to effectively sustain a wind farm. Additionally, wind farms require tens of square kilometers of land, and Singapore simply does not have the vast swaths of land needed. Another possible source of energy is hydroelectric. Rain or melting snow flow together into streams and rivers that eventually feed into the ocean. Hydroelectricity is all about tapping this water, damming it behind enormous dikes, and using it to turn turbines to generate electricity. Singapore might be surrounded by water in the form of oceans, but it is not flowing water, and we lack the rivers that we can dam to generate power. And of course, the favoured child of the renewable energy family, solar. Singapore is, of course, sunny all year round. Surely, Singapore could sustain effective solar power generation. This may not in fact be the case. Firstly, photovoltaics are expensive and inefficient. The energy harvested for the cost of installation is minuscule, and even with large-scale deployment, insignificant in comparison with Singapore's growing energy needs. Additionally, while it might be said that Singapore is sunny all year round, it is just as easy to say that Singapore, as a tropical country, is rainy all year round. Wind, solar, and hydropower, none of these look good for Singapore. Sure, they have their upsides. None of them produce any emissions to pollute the air. All of them are essentially infinite. However, Singapore does not have the vast catchment areas to meaningfully run a hydroelectric power plant. The Hoover Dam, for example, is fed by a water basin area of 637,137 square kilometers, and Lake Mead, the lake directly behind the Hoover Dam, is 637 square kilometers. For reference, Singapore has a total land area of 716 square kilometers. Wind farms similarly need enormous amounts of land to be viable. In the tens of square kilometers, land Singapore can ill afford to spare. Not only that, Singapore does not have the necessary wind speed. It would be possible to deploy solar in Singapore, however, the capital cost would be enormous for negligible effect. Which brings us to our suggestion, geothermal energy. Geothermal energy is the lesser known member of the renewable energy family. Just like the others, it produces no meaningful emissions and is effectively unlimited. Unlike the others, it does not depend on weather conditions, as with solar and wind, and does not require vast swaths of land for deployment, and is, in fact, hardly larger than a normal gas-fired power plant. Additionally, geothermal has the lowest long-run marginal cost of all common power sources, including coal-fired, hydroelectric, and wind. Geothermal has a high capital cost, but over its lifetime, the cost averages out to be lower than competing power sources. But what exactly is geothermal power? As the name suggests, geothermal energy is energy in the form of heat from the earth. Water is pumped kilometers below the ground, nearer to the hotter mantle of the earth. The water is heated up by the rocks, boils, and is recovered to spin turbines in the power plant to generate electricity. No fuel needs to be burned, and no emissions are produced. Non-polluting, nearly unlimited, space conserving, geothermal sounds too good to be true. And in some ways, it is. The only places where it is practical to generate geothermal energy is where there are underground hotspots, like near a volcano. Iceland, for example, uses geothermal energy extensively and is one of the most volcanically active countries in the world. Singapore isn't volcanically active, surely? Well, in fact, Singapore is very close to geological hotspots, namely the Indonesia volcanics, and studies place Singapore within the top of the range in terms of heat flow. Moreover, Singapore has several hot springs, such as the Sembawang Hot Springs, that indicates that there is a source of heat relatively close to the surface which could be tapped for power. Globally, locations with similar degrees of heat flow as Singapore have already built geothermal power plants to great effect. For example, the Philippines, with poorer heat flow in Singapore, generates a significant fraction of their natural supply of electricity using geothermal power. Australia and the United States of America both supplement their power generation with geothermal. Studies have found several potential hotspots for geothermal energy generation in Singapore due to the relative ease of tapping the underground heat reservoirs in these locations. These locations include Tuas, Jurong Island, Pulau Semakau, Pulau Tekong, and so forth. However, Singapore has land constraints, and many of these locations are already built up and urbanized. We therefore propose that two offshore locations, Pulau Tekong and Pulau Semakau, are ideal for building geothermal power plants. In addition, proximity of these plants to two large consumers of energy, namely Changi Airport and the Jurong Island Industrial Complex, would allow for a tighter generation utilization path. This is a satellite image of Pulau Semakau. Pulau Semakau is Singapore's primary and only landfill, where the incinerated ash from Singapore's garbage incineration plants is dumped. It also happens to be a viable candidate for building a geothermal power plant for Singapore. A study has shown that by strategically sinking shafts to a depth of 3.6 kilometers, it would be possible to generate nearly 100 megawatts of power. It is also possible to, initially, sink a single shaft as a test shaft with greatly reduced cost. Of course, having generated that power, the problem of transporting that power to where it will be used is the next obvious question. Fortunately, this is a well understood problem in engineering, and the solution is obvious: to lay an undersea cable. This brings to fore another advantage of siting a geothermal power plant at Pulau Semakau or Pulau Tekong. Not only would it be sited on currently unused land, they are sufficiently near large consumers of energy, the Jurong Island Industrial Complex and Changi Airport respectively, that it would be feasible to lay such an undersea cable.
We do understand that geothermal energy is expensive, but if we can replace and reduce reliance on fossil fuels and natural gas, we can prolong the lifespan and amount of these finite resources. In addition, geothermal energy is more environmentally friendly than natural gas. Hence, we propose the use of geothermal energy in Singapore, and it's a viable option in terms of Singapore being more self-sustainable.